Yeah, so we'll discuss the Industry 4.0. That is what we were planning to understand and yesterday after a brief introduction about the product life cycle. So this is the classification that has been made based on how the technologies has been evolved and developed for manufacturing. And if you see here, and all of us are familiar with the Industrial Revolution 1 actually, because that's a primary industrial revolution everyone studied during the school days. But thereafter, we never heard about the other industrial revolution till people start talking about Industry 4.0. So let's try to understand this classification which some researcher has made. So the first industrial revolution, if you see, it's more about using equipments which are mechanically driven and mostly powered by the water and steams actually. And the source of power is basically main differentiator over here. So all those textile mills, similar equipments, they are supposed to be driven by the steam engines. And that is how the industrial revolution started actually at that point of time. And since then there are a lot of developments happened and the manufacturing is completely keep transforming in each industrial revolution. So we need to understand the key technologies that plays an important role in that particular industrial revolution. So if you see, when we talk about the Industrial Revolution 2, it is basically more the systems are driven by the electrical energy. Yeah, by that time the electrical energy is available. So source of power changed from the steam power to electrical energy, and the concept of assembly line has been introduced at that point of time. So that is how the assembly line of the Ford motors are famous, and people are used to take a inference or the understanding of the assembly line manufacturing from that Industrial Revolution 2.0. And since then, after controllers, microprocessors. So third industrial revolution is more about the introduction of the electronics and IT. That's a communication part. And so the automation, if you see, it has been grown extensively during the Industrial Revolution 3. And that is how all PLCs, automated controllers, in fact, the robotics, all that get genesis during our development during the Industrial Revolution 3.0. And when we are talking about Industry 4.0, now this is a very important point to understand between 3.0 and 4.0. Many times we just carry on the impression that most of the automation and robotics are a part of the Industry 4.0. They are being developed as a part of Industry 4.0. We need to understand the difference, where the difference lies over here. So Industrial Revolution 3.0, as I mentioned, it, most of the automation hardware, most of the automation technologies, whether the mechanical, electromechanical systems, motion control, CNCs, robotics, all has been developed as a part of Industrial Revolution 3.0. Now, when people talk about Industry 4.0, they are talking about the implementation of cyber physical systems actually. So now when I say cyber physical systems means on one side you have an IT technologies or the web technologies or the solutions that are going to run on the computing environment differently at the different locations or in the cloud, and then connecting them with the physical asset on the factory floor. And then on top of that there are a lot of benefits coming out by this simple connect that we will be discussing as we go along during the course. So that kind of a connect has been established, and so between the IT systems and the production systems, and then we will be running a lot of applications on the cloud and the web or the cyberspace. That is what is known as Industrial Revolution 4.0. So that is how, if you see here, as the time scale goes on along towards the right, and we are right now in the era of Industry 4.0, and then people start talking about even Industry 5.0 in coming years actually. So let's not go into the debate of these versions, but we need to understand the core technologies that are going to transform the manufacturing in that particular industrial revolution. So let's try to understand from this graph, which is just depicting how the production systems basically changing from manual production to mass production, and now we are talking about the mass customization. So if you see here, this graph is just showing a product variety and the product volume. And when we talk about mass production, you all understand it's basically producing in a large volume of a similar type of the products. And when we talk about mass customization, we will be talking about a unique product for each customer. And that is what I was mentioning about the batch size of one. Batch size of one means that you will be just making one product for one customer. Then there will be a different product with a different configuration for a different customer. So this is the vision that has been taken when people have introduced the cyber physical integration with the manufacturing systems. And it's not kind of I should say the visionary concept right now, because people have already started implementing the same, and they have already implemented and start delivering services like that. So for example, the technologies like 3D printing are very much on the customization basically, because each component what you want to make is unique actually. You have to just upload the files for one single component, and the manufacturer will be just producing one component for you. So that is how we can say the customization comes into picture. There are few more websites and the services. If you can just scroll on the web and the YouTube, you will get enough understanding and enough material basically to just give you an idea about the mass customization and industry 4.0. So I will be discussing those concepts as well. And our key emphasis is basically to understand the technology component which made or which are driving this industry revolution 4.0. So we will be just spending time in understanding that part. So let me just give you a quick glimpse of what industry 4.0 is and what. So I've just highlighted some of the keywords over here to just catch your attention over here. So when we are in 2022, we are already into the industry 4.0. Now, when I say industry 4.0, what we are expecting over here, so in which computers on one side and automation. So there are two elements. Automation sits on the factory floor with the equipments and the machine, that is the physical systems. And on the other side, we are talking about the computers basically. So it's an IT integration or the web applications or any type of a application that sits in the cyberspace. So in which computers and automation will come together. Now we are trying to, no, it doesn't mean that the automation and computers are not together earlier, because if we say an example of a CNC machine, CNC machine it itself a system which already have a computer embedded to that or inbuilt as a part of the machine itself. So there also computers and automation are there. But now when we talk about industry 4.0, they may not be closely located or they may not be closely connected to each other. So that's an important part, because we'll see the definition in the coming slide, where we will see that how the connectivity plays an important role over here. When we talk about industry 3.0, when the automation was there, the World Wide Web or the internet or the connectivity is not so widely implemented. People have started implementing the machine-to-machine communication, but that not to that degree what we are expecting in industry 4.0 to happen. So please do let me know wherever you are not understanding anything. I will just interrupt and explain the concept to it, because these are the basic foundation of the course that we need to understand why we are learning this, why we are trying to understand these technologies. And when we say computer aided manufacturing, in what ways computers are basically helping people in doing manufacturing more efficiently. So when we say the computers and automation will come together in an entirely new way, that is what is important to understand here. As I was mentioning, computers and automation was there in robotics also, was there in the CNC machines also. Now, when we are saying new way, entirely new way, now people are trying to visualize the applications completely differently. So you have some machine on the factory floor. And now what I'm trying to do, I'm trying to make this machine run, monitored, controlled, or maybe making this machine more intelligent, capable of taking decisions themselves. So that kind of capabilities has been added over here. Now the limitation, if you see that in the conventional automation system, you don't have much processing power as such. So computing is limited to the machine functionalities, and automations mostly implementing the digital logic over there. So basic control logic has been implemented. But when we are talking about the applications which are too much computing intensive, they may not be able to run on the same controller where the machines are communicating with. So that is the way we are finding a lot of potential available to do this kind of processing and computing at a different location. That is what we call it as a cloud computing, and then and cyberspace, where you will be able to do a lot of algorithm, whether it's for the predictive maintenance or maybe to check the product quality. So all that can be done possibly with the connectivity and a lot of computing power that is available today. So in this case, we are talking about use of computers and automations in entirely new way. I'm just emphasizing this keyword again and again so that you all will start thinking in that direction. What could be those new ways? It's not that everything has already been defined. The era where we are working right now, all of us have to learn and then evolve this the generation of industry 4.0. So please start thinking what are those new ways. Now what we are trying to do now we are also using the robotics over here, with the robotics connected now remotely to computer systems equipped with the machine learning algorithms. Now you see that, so the key technologies that are coming into picture, now robotics is coming, which is now remotely operated. And now we are also introducing the data science part of the machine learning algorithms, which make the system learn. And then it will also control the production systems. Now, during this process, we are expecting very little input from the human operators. So that kind of technologies has been evolved as a part of the industry 4.0. Are these terminologies clear to everyone?
Yes, sir.
Okay, fine.
Yes, sir.
So let's see that. Let's try to understand further. So when we talk about industry 4.0, we call the kind of concept that has been evolved and the way the factories are transforming, we call it a smart factory. So industry 4.0 introduced what has been called the smart factory. Now, when we say smart factory, what we are expecting to happen in the factory which is smart, so then we are trying to define it in which cyber physical systems. Now, when I say cyber physical system, I'm sure that you are now clear that we are trying to run some programs, algorithms, softwares on a different platform, that is the cyberspace, whether it will be co-located in the factory or it will be running somewhere in the cloud. And then which monitors the physical processes of the factory. So now data is flowing from your physical systems, reaching to this cyberspace, which will be processing the data. So, and through that, it will also be monitoring the physical processes of the factory. And we also want the decentralized decisions to happen actually. When we say decentralized decision means all decisions are not dependent on one set of people or at one location. And most important part is that we are trying to distribute the decision making power to the equipments. That's a very important part. It means that smaller decisions I would like the machine to take themselves. So that is the way we would like to implement the decentralized decisions. So when I will discuss the design principle for industry 4.0, that time again I will emphasize on this term. But for right now, we need to understand that we want to implement the decentralized decisions. The reason being that we don't want to lose time in decision making. So that is again a process of adaptation. I will explain further. So that will accelerate the decision making process. Now the physical systems become Internet of Things. So that is why we call it an industrial Internet of Things. When we talk about industry 4.0, whenever we talk about smart manufacturing, we'll be talking about industrial Internet of Things, through which your physical assets are now connected. Now they are communicating. Once you establish the connectivity, you will be communicating and make them possible to cooperate. It means that the robot is cooperating with a machine both way, basically to just load, unload the components, try it and inspect the component. So they will be cooperating with each other and also with human. So machines will also be communicating, cooperating among themselves. At the same time, we'll also want the human being also interacting in the same ecosystem. And this will happen in a real-time environment through the wireless connectivity. So if you see here, this definition or this impression, what I have just given about Industry 4.0, now you will be able to visualize the big difference between what we are talking about Industry 3.0, where the automations and the robotics is already existing. And when we are talking about in a completely new way, how we want to build this collaborations and cooperation between the machine to machine and machine to human, is what is making Industry 4.0 different actually. And that is possible with this kind of an accelerated computing systems being available, and they can also be connected within a high bandwidth and high data rate. And now we are talking about even 5G as in a mode of communication on which you will be able to exchange large volume of the data at a very high speed. So all these technologies are enabling this manufacturing to happen in this fashion, and that is how we define the Industry 4.0. So that's a quick glimpse of that, but certainly I will take another lecture maybe after I just finish the basic introduction and understanding about the manufacturing. I will again explain the detailed understanding about the smart manufacturing. And subsequently in the course, we'll also be trying to learn some of the key technologies that is important. Now, when we talk about Industry 4.0, we are emphasizing on these three key terms or three types of production basically to happen. One is certainly the smart production, basically more precise, good quality of a high mix of the component. And now we are emphasizing on low volume actually. So we would like to have large volume mixed together with a different variety of the components. It means that the manufacturing facility is more agile. We will be able to produce a good mix of the components, and it should also be able to adapt to the new demands. The good example is that, for example, if I have some machines or some assembly line, if I want to change the product, basically how that I can do in a real-time basis. Real-time basis means basically immediately after the next batch will be a different product, and then you will be keep on mixing the multiple products depending on the customer demand. Idea is that people are trying to make it as more real time it is possible. Let's see that what is the time scale for the real time. Then we'll also be making more green production system that is a clean, resource efficient and sustainable. That is what the goal should be. So more sustainable manufacturing systems, environment friendly manufacturing systems. Then right now, the production facilities are always kept away from the city. And that is the bigger problem for the urban environment. If you see that people are running from one corner of the city to the another corner of the city to do the jobs for the production systems or the manufacturing plants. Now, in this case, people are planning to have an urban production actually. So once you are having the green production system, once you make the decentralized production systems, the idea of urban production is that to locate the factories near the people. So they will not be running from one plant to another plant or one location where they are staying to the another end of the or another corner of the city to do the production activity. So they will be co-located in the same environment where the people are living. So that it means that you have to make the production system more environment friendly, not creating any kind of pollution, and let the people will be staying around that factory space itself. So that is the urban production is the another, and this also be driven by the concept of the decentralized manufacturing. Let's not make everything in one plant. The idea is that let's try to make or assemble the products near the customers, near the end users also. In fact, there is a lot of change happens in the way you are making a product. Because see, if it is a unique and one customized product for a particular customer, it's very difficult to make that product far away and then try to ship that product to the customer. So people are trying to develop a concept of the speed factory. So I will just give you that example also, how Adidas has implemented the speed factory concept, and then they are trying to build in a small decentralized factories located in a particular geographical area. So it's a decentralized, not everything is not shipping from one factory. They will be making a small factories near the people actually. So that is the concept of the urban production system. So they would like to have a smart, green and urban production. That is what the idea behind implementing Industry 4.0. So when we talk about technologies, this is just a quite quick glimpse of the technologies that we will be dealing with in Industry 4.0. So certainly we need to understand what are the cyber physical systems. The collaborative robots are the another technology which is going to play an important role in this, where you have a human machine interactions possible in a different way. You have smart sensors, actuators, controllers. Additive manufacturing you're already familiar with, so rapid prototyping, tooling, rapid manufacturing, all that will be coming as a part of smart manufacturing technology. The technology like augmented reality help people, basically they are enabling people. So many times we take an impression that Industry 4 and all industrial revolutions are trying to eliminate human being. But here this technology, when we talk about augmented reality, is basically empowering human being. It means it's enhance your learning, it's enhance your understanding about the system, and it's try to give you a view or the vision which you can't see normally. So with a kind of a wearable devices or mobile tablets, you will be able to see the augmented view of the system. So that also we will discuss what exactly this augmented reality is and in what form or in what ways it will help you in manufacturing. Then we talk about the advanced simulations and the digital twin. This technology also we would like to touch upon. Certainly will not be able to cover, but these are some of the new emerging technologies which we need to understand. We cannot be just sticking to what are the conventional manufacturing practices, but when we talk about smart manufacturing and Industry 4.0, we need to understand the both the aspects of the, so manufacturing on one side is the core manufacturing activity to happen, but at the same time what kind of services can be made available when we talk about the cyber physical integration happen. So when we talk about the digital twin, how it is different from the simulations, that we need to understand how it will be helping in the manufacturing environment, that also we need to understand. What type of tools are available to implement the digital twin, that also we need to understand. Manufacturing analytics is coming big way because you are finding everywhere people are implementing data science and machine learning. So they also find a lot of applications in manufacturing for empowering even people to take in a real-time decisions, because once you have a statistic and data available and analyzed in a real time, you will be able to take a better decision. So manufacturing analytics is a bigger driver for this smart manufacturing. We are talking about the remote maintenance. Certainly the kind of scenarios we are dealing with today, that you may not be having an engineer immediately available. First of all, even if it is available, he may not be available at the time you need him. Experts are rare basically, so that you may not be making experts moving so frequently at the different locations. So all these are impacting how the maintenance being done. So there are a lot of technologies which will be helping us in performing the remote maintenance. So it means that as an expert, I will be sitting at one location, but I will be doing a maintenance activity at any part of the geography. So any part of the world. So he can attend the problems, he can understand. So the technology has to enable him to basically get that kind of a real experience as he himself is in front of the machine. So that remote maintenance is a very important driver for this smart manufacturing. Then we talk about the smart sensors. So certainly the instrumentation and then connectivity through the wireless means, because running the wires many times may not be so easy in an old factory. So people would like to use wireless communications, and so the lot of wireless instrumentations has been developed. Now, with the technology, we also would like to improve the industrial safety, because the kind of machines people are using, how we can enhance the safety around those machines. So when people are interacting with that, so not many accidents should happen. So industrial safety should also be enhanced with the implementation of these technologies. And finally, because a lot of information flows in the shop floor and outside the factory, so security is very important. So cyber security is a very important area when we talk about smart manufacturing. So the way you have seen that the more and more transaction or the financial transactions happens over the digital media or the communication methods, there should be enough security. And certainly as an individual user, we may get impacted to some extent, but as a factory, if somebody impact the factory operations, then it is going to be a huge loss for the manufacturer. So security is very important for the data and the communication that need to happen. So certainly these are some of the key technologies, or I should say, the extension of whatever manufacturing we already learned. We need to also get familiar with all these new technologies and try to understand how they are going to contribute towards manufacturing. So we will be learning some of the technologies that are being mentioned over here, and then rest are left on you. If you have more interest, you can anytime learn them yourself. So with this basic understanding, let me give more fundamental introduction and understanding about the manufacturing production systems, and then we'll talk about the automation, CAD/CAM, and then come back again onto this smart manufacturing discussion. So when we talk about manufacturing, I think it's a very fundamental that we need to understand. It all started how you people start making things by hand. So that is how the manufacturing, the word itself says handmade. You have to make by hand. And then slowly you see that the factories, which I'm showing on the right hand side, is the way that people are now manufacturing products in the factories. So there's a lot of transformation as we were discussing. It all started by manual manufacturing, and then slowly as the industrial revolution happens, people develop new machines, and certainly those machines will get automated, and now we are talking about controlling those machines remotely. So that kind of transformation happens in the manufacturing. And when we talk about the production, so now manufacturing is actually where the operations are going on directly onto the product. When we say production systems, then we are talking about many interconnected activities. So then you will be relying on many separate but different functions, interacting functions. We will see that what exactly those functions are. We call them a manufacturing support system should also be there. As we have seen in the product life cycle also, the actual production happen in one of the block, but the rest of the activities are basically to run that factory or the actual facility. And we'll also understand the production systems are today the automated and computerized. Now these two words are also very important to understand. When we say automate, we are talking about the automation of the facility, that is the machine automation. And when we talk about the automation of the manufacturing support system, we will be talking about the computerization. And collectively, we are talking about the digitalization. Today, we will not call it a computerized system. We call it a digitalization. It means that all the transactions, all the activities now happen digitally actually. So you may not be interacting every time on the through the physical medium. You will be using a digital medium for those kind of communication. So that is how the production systems are automated and computerized today. Let's go to a further understanding of the manufacturing. So when we see as an engineer or a scientist or the technologist, we always see is a technological process. And when we say businessman will see is as an economical process. What is the difference? Just a way of you understand, but manufacturing is actually the way the products being manufactured. So when we say the manufacturing as a technological process, we can understand that you are performing some processes over here where you are applying the some physical operations happening on the product. What it will be doing, it will be altering the geometry, the properties, the appearance, so that it will be making a useful product or useful component or useful part, which will further get assembled together to make a final product. So if you see a technological process means I'm doing some operations physically, chemically, electrically, whatever you want to do that, so that you will be giving a shape to the starting material, or you will be transforming a starting material over here. So that's how you have a starting material, which is going as a raw material, which is going into the transformation with the help of various manufacturing process, and you will be getting a finished product. So complete part or the product will be coming out of this. But during this manufacturing process, what exactly you will be utilizing, that we need to understand. So while performing this, you will be requiring the machinery, you will be requiring certain tools over here, you will be requiring power, you will be requiring manpower or the labor basically, and then there will be some scrap or the waste coming out during these operations. That is how we try to visualize. Again, if you have any better version of this understanding, you can also define that way. But we are mainly focused about how the transformation happen, how this geometry is being or the property is being altered while the manufacturing process happens, and what exactly we will be utilizing to conduct this transformation or to make this transformation happen. So it's a sequence of operations. When we say manufacturing as a sequence of operations, then it is we are trying to understand it's a technology involved and to perform these operations. When we talk about a businessman, he always see manufacturing as an economic process, and that's how the difference in the perspective will also be there. And it's a very important aspect to understand the technological process and economic process, because whenever you reach out to the people in industry with the kind of solutions that you are building on the technology, you need to address both the aspects, because a businessman may not be that keen in understanding what augmented reality is and what predictive maintenance is. He understands the economical aspect of it. So when we say manufacturing as an economic process, we are concerned with the transformation of material into items of a greater value. Now you understand that. Now I'm not keen on what shape you are generating, what transformations you are doing to the raw material. I am more concerned with what value it will be increasing into that. So from a raw material to a finished product, I will be adding a value to that component. And then during that, you are doing all the processing and whatever the assembly you want to do. So again, the activity remains same. My perception of looking at the whole thing will be different. So I may be doing cutting operation. Technologically, it is viable, it's fine, it's feasible. But that cutting operation may not be adding a value to the product. So then it may not be in a good manufacturing as from an economical perspective, because I will be spending resources onto that, and then it is not going to add enough value to the product. So that way it is important, whatever activity you will be doing in the manufacturing, whether it is adding a value to the raw material or not, or whatever operations you will be doing, it should add a value to the product. And then we call it some manufacturing being done. So manufacturing add value to the material. So every stage of manufacturing, every steps or every operation or a sequence of operations you are doing, they should add value to the material. And that is how people see manufacturing as an economic process. So let's have a quick understanding about the production system. So we talk about the manufacturing. When we talk about the production systems, we will be talking about the people. We'll talk about the equipments, and we'll also talk about the procedures basically. So even if you have a people, if you have a equipment, if you are not defining the right procedures for manufacturing, then again the whole production system will not complete. There should be in a well-defined instructions, as we are discussing about the process sheets, or the definition means what kind of operations person supposed to do, what kind of parameters to be maintained. So there has to be some procedures by which people are interacting with the equipments, and then they will be making this production happens. So these are the three important elements of the production system. Now, when we talk about the production system, we divide into two levels, as I was emphasizing. One is the factory level, that we call it a facility. Now, facility is where the actual product manufacturing happens. And the second one, we call it a manufacturing support system. So if you take an example of a shop floor, where the actual physical machines are located and then whole operations are going on to the product, that is called a facility. So all factory equipment, layout, everything is coming as a part of the facility. And when we talk about the support system, because facility alone cannot do the production, it can do manufacturing. But when we talk about doing a production activity, then you require a lot of support system around it. So we'll see in detail what all support system are required. You have already seen in the product life cycle what kind of support system is required. So if you just look at this circle, you'll get in that idea. So at the center of this, you have production system facilities. So your equipment, all factory, shop floor, everything is there. Now you see the interconnected blocks being shown over here. And this is again depicting the same operation which we have seen in the product life cycle. So if you see here, there are activities required by which you will be able to collect the orders. And that is how we have understood that all manufacturing activities, all production activities should start with there is a requirement from the customer. So how you will be capturing the customer order, customer requirements. So there are certain business functions to be performed as a part of the production system. So there's a sales and marketing, sales forecasting, order entry, cost accounting, customer billing. All these are the business functions to be done. And once you capture the order, then all these activities, as we have seen, the product concept design, design engineering, drafting, all being done as a part of the product design. Then you have a manufacturing planning, then you have manufacturing control, and all are interacting with these facilities. That's a very important part here. So at the center, you have facilities, and around that, you will be having all sort of manufacturing support system to work to run this production system. And none of the manufacturing facility basically, or I should say any of the manufacturing plant or factory is not running just by the facilities alone. They need to have all these support system around it to make it happen. Actually. So this is very important concept, because when we talk about the technologies, again, we need to understand this perspective. When we talk about the automation of the manufacturing support system, it is completely different set of technologies. And when we talk about the automation of the production system facilities, then the kind of technologies involved are completely different. So let's try to understand the type of facilities. I am sure that you all also familiar, so I'm not spending much time, but just to understand that. So there are manual work systems that people are doing operations by the tools and they're performing operations manually. That is also a facility. And earlier, prior to Industrial Revolution 2.0, people are also, or even 1.0, people are following the manual work systems. But in current systems also, there is always some part of activity done manually by the worker. So that is the manual work systems. Then comes the worker machine systems, means worker is now utilizing the equipments or the machines to perform the manufacturing operations. So then one person operating one machine and he's interacting with that machine to control the operations, and he will be able to convert the raw material into a product. So that is what the worker machine system is. And now we are talking about the automated systems. So when we talk about the automated systems, now here uh, the operation is performed by the machine now without direct participation of an human worker. So now it means that in the worker machine system and the manual work system, the human worker is directly participating in that activity. For example, if we take an example of a lathe machine, then the person is continuously operating and controlling the speed, feed, depth of cut, and then doing the operation. So that is the worker machine system. And when we talk about the automated systems, like we can take an example of a CNC machine. So he will not be continuously participating while the operation is going on. So once he download the part program into the machine, load the component on the machine, configure the machine to cut that part. And after he start the operations, now he may not be required till the part is being manufactured or machined actually. So that we call it an automated system. Again, the definition is there. It's in a semi-automated or fully automated, and then even that we need to understand a little bit what exactly it means. So we have semi-automated systems and fully automated systems. Now, semi-automated system and fully automated system, I always give an example of a washing machine, which most of you are familiar with. I'm sure that you have seen the way it is to be operated. So I just want to understand from you only how you will define the functionality of a semi-automated machine or semi-automated system. Can anyone explain, those who have an experience of at least looking at how the operations being performed in a semi-automatic machine? Can anyone explain? Yes, Mohit.
So when we talk about a washing machine, in
Mohit, just a minute. Let me just put this call on hold. Just a minute.
Hello.
Sorry, Mohit. Yeah, you continue.
So, when we talk about the case of washing machine, in
Yes,
semi-automatic washing machine, there are two sections basically, and one is for washing the clothes and another is for drying. So
correct.
we have to manually transfer the clothes after it has been washed to the
Hmm.
dryer section. But
Correct.
in fully automatic, we don't need to do that. Only one section is there, and
Correct.
whole process is performed in that only.
Correct. Thanks, Mohit. I think you have explained it nicely. So if you understood this, when we say semi-automated means some part of the cycle is being done automated. So washing can be done automated, then drying is taken care of automated, but then there is a manual transfer of the clothes from one tub to the another tub. So that is a intervention of human worker required. So person will be required to do this changeover in between. That is what is the semi-automated part. With some part of the cycle I am running automated, but then it requires a human intervention, and then you will be continuing with the next operation. So that is what the semi-automated. And when we talk about the fully automated, what Mohit has explained is that once you put your clothes into the machine, then till it washed, dried, everything is done and taken care of by the machine, your intervention is not required. And there are different interfaces available through which you can select what kind of washing is required. So machine has all sort of programs inside it. It will also check the cleanliness part, have sensors also integrated into it. So that way, after putting a cloth into the machine, you are no more required. Now, the most important part we need to understand when we say fully automated, again, doesn't mean that everything will be running without human intervention for a very long period of time. So for each batch of the operations, once you load the clothes into it, and then after they get clean, again, there's a human worker required or human operator required. So that is how when we say fully automated, is always talking about an extended period of the time. And that time will keep on changing as the technologies keep on evolving and developing. Today, we say that the fully automated factory may be running for one batch of the production or one batch of the jobs, or maybe running in a one complete shift of the production fully automated, or we may say that may be able to run for a week or so. So that way, we can't say that the fully automated factory is always running in an automated way without any human intervention required at any point of time. That is not available today. So when we say fully automated, it's always for an extended period of the time, and that time scale will keep on changing. So if we see here, semi-automated perform a portion of the work cycle automated, and when we say fully automated, operate for an extended period without human intervention. And this extended period is something is a function of the technology and the time when you are talking about the fully automated systems. So if people were talking about the fully automated system 10 years back, their definitions will be different. And if you talk about the fully automated system in 2022, the definition will completely different actually. To what extension you will be running the whole system in a fully automated mode. So that is the basic understanding of the automated system. Again, not going too much into detail because when we discuss automation, then we'll understand that even better. Now we talk about the production manufacturing support system. Earlier we have seen the facilities. We understood there is a manual system, there's a worker machine system, there is an automated, fully automated, semi-automated system. So we are talking about the machines basically or the facilities that are operating in the production system. Now, when we talk about the manufacturing support system that is going to help to perform this production in the facility, this support system is not directly in contact with the product. It means that the salesperson may not be directly operating something and then helping us in converting the raw material into the finished product. He's only collecting the orders, how much to be produced and for which customer. So it means that the support systems do not directly contact the product, but they will be very much useful in planning and control the whole production activity or the progress in the factory. So because facility will produce only as much number of the orders being captured, how many to be produced in a day. That is how the role of the manufacturing support system is very important. And as we have all seen that the planning and scheduling is also a very important activity to be done. Even quality control is very important activity. So this manufacturing support, again, they are exchanging the information, and most of the activities in terms of the automations are the IT technology integrations or the information exchange. So when you talk about the ERP systems, that is certainly an automation of a manufacturing support system, where you are passing on the information from one department to another department, or one unit of the manufacturing system to the another unit of the manufacturing system. So that way, manufacturing support system is also very important component of the production system, but they are not directly in contact with the product, but they will be also be utilized for planning and control of the manufacturing processes. Now, when we talk about the automation in the production systems, again, as I was saying, we need to divide the automation in two different parts. Again, automation of the facility, and we talk about the automation of the manufacturing support system. So that's how we are just trying to put into blocks over here. When we talk about the automation in manufacturing systems, and then we talk about the computerization of the manufacturing support system. So now when you see the terminology here, automation, it means we are doing something on the facility. It means I'm adding an actuator, sensors, I am doing some part of the operations automated. Even picking a job and loading into the machine, that's an automated operation to be done on the facility. So that is coming all as a part of the automation. And when we talk about the automation of a manufacturing support system, it means that I would like to capture the data from a field by the salesperson, and then I would like to inform that data to the factory. So that kind of an information exchange happens with the person who is carrying the tablet, and once he submit the information, the data is being coming into the database into the factory, and then a person responsible for controlling the production or scheduling the production, he will understand what to be manufactured now. So that kind of information exchange happens with the help of computerization of the manufacturing support system. Now, when we talk about the facilities, let's see that what all automation we have seen, just a small list, but then there may be more automated operations you can have. All sort of processing happens on the raw material, assembly of the components, inspection, material handling. All these are the automated operations happens in the facility, and we talk about automation technologies to work there. When we talk about the manufacturing support system automation, we will be talking about the IT systems being placed. So you have computing hardware integrated servers, and then you will be having a different mobile applications or the system based applications through which you will be interacting and exchanging the information. Now, when we talk about the computer aided manufacturing, that is just simple block diagram which shows you again very limited scope shown over here. These days we already have a much wider scope for the computing integrated with the manufacturing. But idea is that we will be using computers to plan, manage, and control the operation. And this is just showing in a block diagram for a CNC machine. So you need to use computers for designing the product. So we have a geometry creation with the help of CAD. You have a tool path generation with the CAM. Then finally you will be generating the G and M codes, basically the part program out of the CAM software. So once the tool path is generated, and then you will be generating the G and M codes, which can be transferred to the machine for execution. So that is how the machine which will run this part program and do the operations. So that is how we will be utilizing computers for helping in manufacturing. So we will be designing and then controlling the machines with the help of computers. When it comes to use of computers, we can use computers for monitoring, or we can use computers for both the operations, monitoring as well as control. So that is the part we need to understand over here. So if you can see here, I think, yeah. So if you can see the direct application means I will be utilizing the computer over here, where only one way data exchange happens, and some of the IoT applications even in the smart manufacturing are being done in this way, where the data from the machine is continuously captured and monitored. So all sort of dashboard applications, if you can see the all sort of dashboard applications, they are kind of this one-way data exchange between the machine and the computing system. If we take an example of a CNC machine where you have a controller which not only monitor the progress of the component and then it will keep on showing where the actual real-time coordinates of the tool with respect to the workpiece that can be seen over here. But at the same time will also be interacting and giving command to the machine. So there will be some control signals going to the machine. So you will be having a two-way exchange of the data. One way to monitor the actual operation happening in the machine, and then on other way you will be transferring some of the control signal to the machine for better control of the product. So that way computer can be used for monitoring as well as for both monitoring and the control. Now when we say the indirect application in the support system, so computer we are using now not to control the operations in the machine, but we will be using computer in the support system, which will support the production operations in the plant. So for part programming, like we are running in a CAM software, we will be generating the part program, which is nothing to do here. After you generate the part program, it can be transferred to the controller. So in this case, we'll have a system which will be generating offline the part program. So anyone sitting anywhere can prepare the part program, may not be required at the facility. So NC part programming, computer-aided process planning, production scheduling, material requirement planning, shop floor control. So all sort of systems that are being evolved with the help of a computer and connectivity that will be done to support the manufacturing support applications. So that is how the computer-aided manufacturing we need to understand both in terms of the facility level integrations and also in the support system. Yeah, so it's already 11:54. Let me stop today's lecture and we'll continue discussion tomorrow on this. If you have